Okay, so this is the final review assignment for the R sections, and this is radical expressions. So we're going to knock this out, and we'll then be finishing our homework this week. Next week we'll start the week off with a quiz, and then we will get ready for our first test over all the review sections. So just to get started, so some rules for square roots and cube roots. So here's a rule. So what I'm going to do is I'm going to give you the rule, and then we'll look at how it can be used and maybe what are the benefits of it. So if you have the square root of A times B, it's the same as saying square root of A times square root of B, or vice versa. I tend to think it works better going the other way. So an example, so we'll call this example 1. So I'll give you a couple of examples, and it also works for cube roots. So the cube root of A times B is cube root of A times cube root of B. All right, same rule. All right, so we'll do maybe an example with a square root and an example with a cube root. So, all right, so example 1. We'll just say evaluate. Try to evaluate this completely. So let's say you have square root of 2 times square root of 18. So there's your expression. Which, again, the idea is to make this problem as simple as possible and try to work it without a calculator. Well, do you know what the square root of 2 is off the top of your head, the actual answer? No, it's not a perfect square, is it? Is 18 a perfect square? No, because something times that same thing doesn't give you 18. So right now, it's kind of cumbersome like this. However, if I look at the property says this: if you have 2 square roots multiplied, you can make it 1 square root of multiplication. So equal signs work both ways, left to right, but you can also go right to left. So what I'm going to do is I'm going to say, well, I'm going to make it 2 times 18 under one square root, which then, 2 times 18 is 36. So by combining the 2 separate square roots into 1 square root, now we have a perfect square, and now it's easy to answer. The answer is 6. Okay? All right, next one. Evaluate. Cube root of 4 times cube root of 16. So same idea. I don't know the cube root of 4. I don't know the cube root of 16. So can you combine those into 1 cube root and hopefully have a perfect cube, and then finish the problem from there? And then after you get that one done, explain to me what's the shortcut for this part C. That's all the same type of problem. Okay, so if we go and we make this 1 cube root, we get to the cube root of 4 times 16, which is the cube root of what number?
64.
And is that a perfect cube?
Yes, sir.
It's what?
4.
4. Okay. And then what can you basically say happens anytime you multiply a square root by itself? It cancels, because now you basically have 13 times 13, which is already a perfect square, so your answer is, so we're probably from here on out, just skip that step and go straight to there, okay? All right, works the same for division. So the square root of A over B is square root of A over square root of B, and the cube root of A over B is cube root of A divided by cube root of B. So both of those work the same type of rule, and it works for fourth root and fifth root and so on. I'm not gonna keep writing it out for all those. So let's try this one. So part D, we have the square root of x over 2 times the square root of x over 72. It's going to be, try to simplify and write without any radicals. You know, how can I simplify it as much as possible? So try that one there. Square root of x over 2 times square root of x over 72. See if you can work this one out. Let's not have our phone out, please. Let's put our phone up. But if you want to sit there and charge it, I'm going to allow you to do that, but you need to put your phone up. Out of sight, out of mind. There you go. Okay, thank you. All right. So what happens on this one? You can multiply, what was that now? That's all right. Yes.
Okay, I think I have one of your friends out here. Is it Stapleton?
I think I'm the wrong class.
He was, did